Hi everyone, welcome to a ROS2 Q&A video here at the Construct. My name is Rodrigo, and here we answer common ROS2 questions posted on the popular site ROS Answers. I found this one that is about Gazebo in ROS2. Basically, there are a couple of things that need to be looked at for changes in the way we use Gazebo for ROS1 and ROS2. So I'm going to take a look at this question right here, in which this guy Andy is trying to create his own simulation, right? And he's using the popular plugin for differential drive in order to be able to move it. And he has a problem. He can't see the odometry topic. And I don't know if it's the same for the command vel. It doesn't say right here. But the main problem here that he says is that he can't see the odom topic, which is published by the differential drive plugin in Gazebo. So we'll take a look at how you can do this and the quickest way possible. And the way that I do it is I just compare my URDF, Chakro, Gazebo files with an established one. In this case, my favorite one is the Turtlebot 3 because it's already out there for everyone to look at, and you can see how they implement the plugins and then compare to yours. So if we go back here, down here, you can see that this is the plugin that he's trying to implement, the ROS diff drive plugin. And here he's the URDF file. So I'm assuming in one way you're calling to this Gazebo plugin, which is usually in a separate file than the URDF, in order to get that plugin. So let's take a look at how the Turtlebot 3 does it and how we can kind of figure out what's going on here. So the first thing, before we do anything, I want to advise Andy here that he should make sure that this plugin is being recognized, right? So maybe add another one like a ray, like a laser scan one or an IMU in this same file, and then trying to see if once you launch the simulation, it gets recognized in the output. If not, then something's wrong with the structure of your file, but it looks like it's good. So because it's got the Gazebo tag first, so like right there, the Gazebo tag, then plugin, and then the plugin information inside. And my guess is we're missing a couple of things here. So let's take a look, you guys. Let's go. Alright, so we're going to be using our Turtlebot 3 simulation that we already have prepared here. So for this, we're going to start our website, theconstructsim.com, and you can create an account if you don't have one real quick. I already have one, so I'm just going to click login. Alright, and once you're, let me make this big so it's clearer. So once you're in the home page, you can go over here to my ROScheck section, and then I'm going to be sharing one ROScheck with you, which is a virtual machine that has all the work prepared for you for the Turtlebot 3. So I'm actually going to be sharing this ROScheck with you guys, which is a sandbox for Turtlebot 3. I'm going to be sharing this link right here. And all you need to do is just click on the link that I will post down below in the description, and something like this should show up that you copied the ROSchecks. So we're just going to go ahead and click run. Oh, sorry. Just click run here. And while it's loading, let me show you guys our latest workshop, which is ROS2 RMF Fleet. It's one of our latest training, which is robot fleet management. So in case you want to figure out how you can control fleets of robots, not just one robot, but fleets of them in your environment, take a look at our new training that we have. It's a 3-day online hands-on training in which you will be practicing with real robots in order to implement a fleet management system that you'll be able to implement in a variety of applications. We have here our robot cafeteria. You can connect remotely and you can practice on the fleet management that we are presenting, which is the work done by Open Robotics. It's called Open RMF. So it's an open source fleet management system. So thanks to them, we are able to provide this training. So if you're interested, also, I will leave the description down below in the video so you can take a look at this page and see if it's interesting to you. All right, so take a look, you guys. Now, we're gonna go back to our ROS check, which it seems like it's loaded. So here's the notebook and you can see bunch of little instructions here. And before I do this, before I launch the simulation, let me just show what I'm talking about the Gazebo plugins. All right, so you can open the IDE with this button right here, and then all of the, let me collapse it so it's more understandable. All of the files that in your ROS check will show up. Here, I'll close this. So in here we have our Turtlebot 3 workspace, which contains all the packages to launch our simulation. And we're going to try and find where that plugin is, the differential drive plugin. So it's usually simple to find because if you follow the correct nomenclature, let's say, of packages and simulations, you'll find that everything that's needed to be launched for the URDF, things like that, it's in the Turtlebot 3 description package. So like something description, so this one right here. Here you'll see that you have URDFs for the robots Turtlebot 3 burger, Turtlebot 3 waffle, etc., etc. And then for everything that's needed for Gazebo, they usually are stored in a Turtlebot 3 or whatever your robot is, and then Gazebo. Again, this is if the robot follows a correct, let's say, standard nomenclature of the structure of how to organize your project. So if we see here in the Turtlebot 3 Gazebo, we'll find those plugins. This is actually not that great of an organization, but it serves our purposes for this video. So this will actually be, we're going to use the Turtlebot 3 burger. So we're going to go into the model.sdf. Now, you can do this like this, but usually what you do is you have a gazebo.shacrow instead of this SDF that is called by the URDF file found in the description. But again, this is good enough and it's good for our purposes. So here you can see that, I'm sorry, it defines the Gazebo elements, let's say. So for example, collision properties, the IMU sensor, things like that. So in here, if we do Control F and then type diff, we'll see that we have a plugin that is suspiciously similar to the one that we saw in ROS Answers by Danny. So let's look at this. We see that we have a plugin and we have a bunch of parameters. And this is why I said it's probably the fact that it has missing parameters. And for example, let's see. So if we were to turn this off, oh, sorry, I'll just cut it. And we'll just compile and launch again. So we wouldn't be able to see the odometry and the command vel things. So if we go here and we'll just copy this and paste it right here in order to launch our simulation. I'm doing an update here because this virtual machine doesn't have this package Dynamaxel SDK integrated, so I do that to install that package before launching the simulation. Alright, so now we launch the simulation and wait a bit. You can see that this Gazebo window opened up, and we can see that we have our robot here, and that blue thing is the LiDAR sensor that's being visualized. You can turn that off, but it doesn't matter. So now we can open a new one, a new terminal, sorry. You can do it in this button here. And let's check the topics. Here we can see that we have things like a scan, TF, IMU, but we don't see any autumn or command vel, which makes sense because we deleted that plugin. So let's bring it back and launch it again while comparing it to the post that we're trying to help out. So now we can just bring that back. Notice here how there's an odometry frame and also some things that are commented. The command topic parameter and the odometry topic parameter. So I think in ROS1 you didn't have to specify this, and I think this is the problem here. So if we look at the Gazebo plugin that Andy is, I hope I'm saying the name right, yes, Andy is implementing, you can see I can't see a command vel topic or an odometry topic. So my guess it's simply just that. So you can actually take this template and just try and paste it and see if that does it. Again, considering that there's no issues in the structure of the files, maybe you do a mistab or something that is not recognizing the plugin, but hopefully that works for you. And then we can just go ahead and compile and launch again. I'll just paste this again. Although actually we just need to do it from here. And actually we only need to compile the package that was modified, but I mean, it doesn't matter if you have not that many packages. So now we'll launch it again. Oops, sorry guys. I didn't make this bigger. All right, so once we are here, we can see again the robot is there, and let's check the topics again. There you go, we can see new topics, command vel, autumn. That's promising. So let's echo the autumn, for example. Nice, we're getting information. And for example, let's try and move it. ROS2 run, tally up, twist keyboard, up, tally up, twist keyboard. And if we press the keys, we should be able to see it move. Great. And now if we want to get super stringy here, we'll take a look at our odometry and see if it's changing. That way we know the plugin is working. All right, so ROS2 topic, echo autumn. And then over here, we'll just move it. So you can see, you might not be able to see it, but because this is the twist information, but you can see I'm moving it back and the linear is negative. Moving it forward, the linear is positive. Now, for example, let's do twists. We should see the angular velocity. Yeah. And then the other way, it's positive. All right, so basically, yeah, that's it. That's all you need to check. Make sure that your plugin has all those two parameters. And my advice then would be to take a look at an established Gazebo package for a simulation. You can use this Turtlebot 3. There's a new Turtlebot 4, so you can take a look at that. That it's already out there. There's a Robotics MP400. There's a bunch of robots for ROS2 that are already out there. You can just kind of take a look at how they're done. We have a lot of more robots from people that just do ROS check like this, that you can, if you join us, you can just, if that ROS check is public, then you can take a look at all of the ROS2 robots. And yes, that's it. That's it for me today. I hope this was useful. And again, please take a look at the links in the description for the ROS check, and also for our training, our 3-day training for robot fleet management that we're doing here at the Construct. If you're interested in knowing how to control fleets of robots with ROS2 and things like navigation already implemented, take a look at the description and join us for our training. And that's it for us, guys. See you guys in the next video. Bye bye.